exercise 5. This is optimization exercise here. And we have a function, a parabola 6x minus x squared. This is the red one here. And we see that they have drawn the graph from 0 to 6 on the x-axis. And they're also putting a right rectangle under the graph. And the thing is, we're going to find the exact value of a, which maximizes the area of this rectangle here. So we need to find an area, the area of this rectangle, and the area of rectangle is length times width, like this. And then we need to find an expression for length and width here, and or height, length times height, whatever. And let's start with the length here, this one. And the thing is, we need to actually know which point this is. This is the 0 point of the function, and it actually says here what this is. But if you want to be completely sure, I want to find the 0 points of the function, so I have to put this equals to 0. You can do this in cos, and then you get two solutions: x is equals to 0 and x is equals to 6. So this is this here. And the point is that this width here, this is put symmetrically under the graph, so this side is the same as this side, right? But so this thing here, if a, for example, is the point, let's say 2, 0 here, right? Then this will be 2, and this will be 2. So this thing here will be 6. 6 is the whole thing, minus 2 minus 2, right? If a is 1, 0, then this will be 1, this side here. If the x coordinate a is 1, this will be 1. So then this will be 6 minus 1 minus 1. So the thing is that to find the width here, you have to take 6. The length, length is 6. But you have to subtract the x coordinate of a 2 times. So, and the x coordinate of a is small a here. So it's 6 minus 2a. Okay, right? So a is 1, is 6 minus 2 times 1. And the height here, let's change this to h. The height of this rectangle here is the y coordinate of this point D here. If the point D here is like 3, then the height is 3. And how do we find the y coordinate of the point? We put the x coordinate into the function. So the height is f of a, right? And if I put a into the function, I get 6a minus a squared. So here we have the length, here we have the height. So we have a function here, we can call it a of, or big F maybe, I don't know, like this. So it's length times height. And then the length is 6 minus 2a. And the height is 6a minus a squared. So this is the area function. The function which gives us the area of the rectangle here. And to find, and we want to maximize this area, we could multiply them, of course, and we will get a third degree function here. But we can just put it in like this on cos and find the maximum point. So I will show you how to do this in cos here, find the maximum point. You could do it by hand, of course, as well, by finding the derivative and so on. But this is the hard part in these optimizations exercises, to find kind of the function here. But then we only need to find the maximum of this. This we can do in cos here. So we just write in the function f of a colon equals 2, and we have 6 minus 2a times 6a minus 2 minus a squared, like this. I want to find the maximum of this. Then we can do like this: f derivative of a is equals to 0. This is an equation, so I press x equals 2. So we get two solutions. And a here is the x coordinate of the point a here. So a has to be positive. So we can get about the negative answer here. So but I forgot the question here. The question was find the exact value of A, which maximizes the area. So, and then you have to use cos if you want the exact value. So this is the exact value here, A square root of 3 plus 3. But we should just confirm that this is a maximum point and not a minimum point. And remember, we can do like this then. We can put the x coordinate into the second derivative, square root of 3 plus 3. And we see then that we get this is a positive answer because this is of course bigger than this. So we get the positive answer, which means that the graph is smiling. Sorry, this is not a negative. So this is not the answer because this is the minimum point. Yeah. Yeah, sorry, I forgot. This is wrong. Let me try again. Yes, square root of 3 plus 3, we get a positive answer. So this is actually the minimum point, but we want the maximum point. So it's this point here. This is not a negative number because 3 is bigger than this. So let's check that this is the maximum point. You put the x coordinate of this point into the second derivative, and we get a negative answer, which means that the graph is angry, and then we have a maximum point. So the answer here is this one, A equals to minus square root of 3 plus 3. That's the answer on this exercise.